Mm, haven't done this in a while. Okay. Working out the bugs, working on my lighting, working on the audio, and everything. Okay. So, if you follow my channel in the past, it's awesome. But if you're new, kind of want to do a little quick video on humanoid robots and kind of what I've been doing lately and thinking about lately. So kind of getting back a little bit into podcasting, just my thoughts and everything going on. Lighting's noise level is really good here, but the lighting is kind of off, so I'll have to fix that for next time. But to start off, my name is Michael Overstreet. I've been doing robotics for a long time. So kind of my history for people who don't know me. Uh, you can read it if you want. The big thing is I've been doing robotics since I was a grade school kid doing first robotics, first robotics Lego of LL. Then in high school, I did FTC, First Take Challenge. Then I also did FRC my junior, senior year. So I've been involved in robotics for a long time. When I got out of high school, uh, I mentored first teams, and then I got involved in a really cool event called Robo Games in Bay Area, uh, put on by David Calkins. Unfortunately, it has gone kind of sort of gone away, maybe forever. But I won a lot of medals there. Usually, I do humanoid robots. I'm also now a robotics facilitator at the Ignition Lab in Kansas City, Missouri. Um, so I'm big into STEAM robotics. So I'm going to do a kind of quick presentation of kind of my thoughts on the state of humanoid robots today. So the main talking points are getting humanoid robots to be durable, getting humanoid robots to repeat their actions over and over again without failure. What happens if there is a failure? How does humanoid robots recover from that? That's a huge thing. Uh, and then for humanoid robots to become mainstream, we need to talk about unit cost or cost per hour. Uh, and then the thing that the reason why everybody's talking about humanoid robots now is because of the ability of AI to help train them and make them actually do productive, meaningful work that people will actually pay for. Then you got your battery life per charge. And as you can see, humanoid robots are extremely complex. So many elements are needed to make them useful in the factories and in homes and be basically our kind of butlers or assistants. Complexity level is unbelievable. So these are kind of pictures of me doing things that I like to do, hang out, talk to people that I know about robotics, go overseas to Japan, South Korea, and so on. A lot of these friends I met at Robo Games, which is really cool. One of the great side benefits of Robo Games is I got to meet a lot of people who live throughout the world, and I, of course, I'd like to talk of robotics as much as I can. So Robo Games is like I says where I got started. I think my first competition was 2005. I don't think I was there the first year, but it's was a robot competition in Bay Area. People from all the world were there. So when people think about Robo Games, they usually think about BattleBots, the big BattleBot arena. This is what they think. Oh yeah, yeah, and of course they got BattleBots in Vegas and so on. So when people think about robot competitions, this is what they usually think about. Now, this is what I think about. This is a kung fu match between two humanoid robots. This is what I enjoy. This is what I think is very cool. This is what I did in Robo Games for all those years since 2005. So these are from various competitions, Robo One and other competitions in Japan, South Korea, and the US with humanoid robots. Always very cool. Not quite as destructive. You don't destroy the other robot, but you can damage it. just some cool pictures. This is what I think about when I think about humanoid or robot competitions. Now, uh, some of these slides are generic and AI created, but a robot is basically almost anything that is autonomous that you can program. Uh, Almost anything in the world now is a robot because almost everything we use nowadays has some kind of computer brain in it, and we tell it to do something, and then we expect it to do it. So the concept of what a robot is very, very, very generic. Can almost be anything. So uh, humanoid robots are trying to mimic us, and this has been going on for hundreds, if not thousands, of years. I think the Chinese had robots and Japanese had tea robots and so on that would serve tea to people. They had gears and made out of wood, gears and pulleys and stuff that would move the robot around and perform an action, a pre-programmed action. But the big thing is they're trying to mimic us. So when I tell this story, a lot of people don't quite get it. But when I was a young kid, I watched a rerun of Forbidden Planet. And in Forbidden Planet, you never see the aliens. You only see their instruments, their doorways, the buildings they made for themselves underground. And uh, the cool thing about it is it lets your imagination go wild. You saw that kind of not a rectangular doorway like our doorways. You saw kind of a triangle, squatted triangle, square, not even a square doorway. And the reason why that was so fascinating me is because the reason why I'm so interested in humanoid robots is because in our environment, we have set up environment for us, two legs, two arms, our general shape. Uh, our environment is set up that way. Humanoid robots give you the capacity or capability to not change our environment to suit the robots. That's all this slide's about, really. So one of the interesting things that I always had conversations with at Robo Games was why a humanoid robot? A lot of people have a really valid argument in that function is it creates your form. Humanoid robots is basically form over function. Uh, so not a humanoid is not perfect for all stuff. Uh, we have, of course, we have other like horses and um, other animals that we use in the farm and other places to help us do stuff. And so their form is works better. But we also designed after we figure out a form, we designed the environment around them or the tools around them for use. So that interesting debate that I always have with people and usually goes is form more important than your function, or is the function end up creating the form, the ideal perfect form? I still don't think that debate is over, and I don't think it ever will be over. I don't think a humanoid robot is the end all be all, but also I'm a big proponent and a big advocate of humanoid robots. And should they look just like us? I don't know. Maybe in some situations they should just look just like us. In other situations, maybe they should look like um, a really powerful gorilla or a really boxy um, robot. I'm not really set on the form like some people are. Doesn't have to look like us, I guess, is what I'm trying to get across. So these are just some different forms. I'm not trying to advocate for this robot, but these are different forms that I've seen. You don't have to have a legged robot. You can have a robot, a humanoid robot on a wheeled platform. I think everybody just needs to kind of think outside the box a little bit. For a pure humanoid form, that's great for a lot of jobs, but I think we can be flexible. You don't have to be it has to be a humanoid robot. You can be flexible in your design approach. Now, I love this picture. A lot of people may know who this is, but I don't think you need to be stuck on two arms and two hands. There's a lot of advantages to having three arms and three hands, or having even four arms and four hands. This don't get stuck on it has to be exactly like us. So maybe we can find a middle ground from that form over function or function over form debate. This is all this picture is about. I've seen uh, I've seen robot arms that you can attach to yourself that could hold things for you. That's more powerful than your arms and help you hold and carry things. So you can attach them to your waist or to your shoulders and use that to pick up heavy weights and stuff. Kind of like an exosuit, exoskeleton. We don't have to get an exosuits and exoskeletons in this talk, but I think exosuits and exoskeletons are a very viable way to make us not like robots, but can do a lot of the functions that a robot can do. So hardware, I've been having talking about some hardware already. Hardware is really important. A lot of people are saying that hardware is solved. I don't see that yet. There's still a lot of work that needs to be done on arms and legs and especially hands. I don't think we perfected robot hands yet. Uh, so you can't say that humanoid robot hardware is done. We still need to iterate. We still need, after you get millions of humanoid robots out in the world, then maybe you can say that we don't need to iterate as much. Get them out there, get them to use, see what is most effective, see what you need to improve on your designs. This is example of uh, servos, actuators. I used to call them servos. I think everybody's now calling them actuators. But there's a lot of companies out there that are producing actuator servos for the humanoid robot. This is Robotis servos, Condo is the other. Let me tell my the story. This is kind of a myth, a legend. Now that I've kind of talked about actuators and servos. So this is the legend of hobby robots that I have learned over the years. So back in the early 2000s, 2001, 2002, in Japan, there's a Honda robot called Asimo. Very expensive robot, very high-end robot, extremely expensive, hard to manufacture, build, and so on. So there was hobbyists in Japan. Of course, the culture is kind of leaning toward liking robots a lot better than like the American culture who's been brought up on Terminators. But in Japan, a lot of the robots are heroes. So some hobbyists were like, I want to build an Asimo. And then coincidentally, around the same time, Kondo, which is a servo actuator company in Japan, made RC hobby servos, came out with these really high-end, very expensive, high torque, steel geared servos. And people saw that and they started buying, you know, 15 or 20 of these to try to build their own humanoid robots. Kondo was like shocked and surprised by this. They thought hobbies would buy one and they would use it at one of these servos on a helicopter or airplane to actually, to move the ailerons, the blades, and move things on an airplane. Uh, so they were shocked and surprised. So they sent out people to investigate and talk to these individuals that were building humanoid robots, trying to build humanoid robots. So Kondo soon after came out with some of the first hobby level humanoid robots. Some of them couldn't walk very well, but that kind of started the craze. So Asimo and the humanoid robots I feel kind of started this craze of everybody thinking humanoid robots were the future. Just a cool little story. I like to say it's maybe a legend, but that's kind of what I heard. I really don't know the names I can associate with this group, but it was a group of individuals, hobbyists in Japan. So in effectors, these are basically hands. This is where I think a lot of work and design and improvement needed to be done. This is where I think we need to think a little bit out of the box on this. I don't think we need four fingers. I think we could get by with three or two fingers. Maybe, maybe we need more than one thumb. I think we need to think more what the hand's going to do and how dexterous or how small of an object the hand needs to be picked up. Lots of tactile sensors and pressure sensors are needed because you don't want to crush something. So if you're in the house and you're picking up a baby or a pet or something like a glass, you got to be very careful that you don't use too much force and crush and damage something. So we'll talk a little bit about robots in the home, but I think that's something that needs to be thought about a little bit more, the safety and so on. Another example, this is a Tesla example of a hand. That's an egg, that's a raw egg. And yes, we're going to, you've got to be very careful. You've got to have hands that will not crush things. Crushing things is not an ideal situation, especially in the home. So when I talk humanoid robots and robots, I always liked adding 3D printing in this because I'm kind of known for that in the past, using some of the early DIY 3D printers to create robot parts, and I still do that today. It's a quick and fast and easy way to create something from your imagination, get it working and using it, so you can quickly iterate. I'm a big fan of iteration. Design something, use it, figure out what's wrong with it, quickly iterate, create a new one. 3D printing, in my mind, is a great way for this iteration. May not be the greatest thing to do for mass production, but innovation, creative iteration is I think is awesome with DIY 3D printers. Well, not even really DIY anymore. The cupcake, what's been around since what, 2010, 29, 2010. So I think when I first used a cupcake and it was like useless. And now most of the 3D printers are really, really good. You don't hardly have to, you just print the thing out and you're done. So this is one of the things I want to kind of highlight. Right now, I don't think the battery technology is there. I think most of the information I'm hearing is about 6 hours for a human-sized humanoid robot on a battery charge. And usually what happens is that you get near the end of the battery charge and things start not working quite right. Your sensors don't work quite right. They're not going to have power. It's not got a lot of enough lifting power and so on. So I still think there's a lot of work need to be done in this, especially if you're thinking a humanoid robot is going to replace a human, because most humans can work 6, 7, 8 hours a day easily, or that's kind of conditioned for us to work there. If you want a humanoid robot to do double and triple shifts, work 24/7, how are you going to do that with existing battery technology? I don't have a solution to it. I'm just saying that's something that needs to be thought about because not only does it have to have uh, enough battery life, kilowatt, what, kilowatt hours, uh, it can't be too heavy. If you got a heavy battery and your whole chassis of your humanoid robot is designed just to carry that battery around, how can it be effectively carry around anything else? You overtax the servos and actuators because you have a huge battery because you want a 18, 20 hour battery life, and you got this huge battery that takes up all the space inside the humanoid robot. So here's some examples of some Tesla batteries, and these are just different form factors. Of course, there's Panasonic and so on. I'm hearing that some of the latest battery technologies, like the 4680, uh, could solve a lot of this, but I think it's all so new and so expensive. It may take a while for uh, these new advances in batteries to help in the humanoid robot area, or just robots in general. Okay, so this is a huge topic. I probably could talk about this topic for hours. But the reason why I think robots and humanoid robots are becoming talked about more and more is that the capability to train the AI in the humanoid robot to do tasks that are beneficial, that are worth paying money for. Um, it is so complex. This area is so complex and changes so much on a daily basis. Um, I still think we're years out before um, this is going to be a solved, not even a solved problem, but just partially solved problem. And AGI, I don't know if we need AGI, artificial general intelligence, to make human and robots effective. But it just there is a lot of work. I mean, to train a robot nowadays through videos for teleoperation, you've got to basically train it on one task at a time. And thinking there's millions of tasks that we do every day that we don't have to be trained on to do one at a time. We can learn parts of a task and then we can use our brains to put all these little subtasks together to complete a major task. Uh, yes, a lot of people talking about, oh yeah, 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 it's easy, we can do this, but I think there's still a lot of work that needs to be done getting a humanoid robot to use AI to do a task it's never done before. So I've heard a lot of people talking about emergent behavior with AI. So far, it looks like it's just a coincidence or just luck that an AI can do something it's not trained to do. So until I start seeing evidence that AI can do emergent tasks that it has not been trained on, then I'll be more optimistic about this. I just think there's so much work to be done. And then AGI is a long way away. You know, I'm not, it's not happening in the 6 months. It's years away. I just don't think LLMs are the path to true AGI. Token creation, token generation. I just don't think that's, I mean, it's a way to learn and it's a way to create AI, but it's not really how we think, work, function, combine tasks together, and so on. So, like I said, it's a very complicated, very complex topic. I could probably spend hours talking about this topic. So, but yeah, this is more reinforcement of AI algorithms, AI learning, machine learning, reinforcement learning, supervised, unsupervised, deep learning, all that, all these complex things that are AI. And again, I reiterate, I've seen AI hallucinate. I don't want an AI to hallucinate when it's picking up my cat. I don't want an AI to hallucinate when it's picking up somebody's baby or somebody's kid and accidentally hurt the pet or the baby or the kid or something. So we still have to solve a lot of these problems. And so this is a term that I've been hearing a lot lately, which is basically physical AI, which is the concept basically, how I understand it is AI can only become artificial general intelligence if it has a body or form to move around and interact with its environment. Kind of like us. We become smarter as we move around and interact with our environment. We talk to our environment, we pick things up, we move in, learn, and so on. I mean, as far as I know, AI is basically trained on data. You don't basically have a robot walking around learning stuff. Uh, you basically use teleoperation, you use lots of videos, and then you try to train the AI, which then after you train the AI can manipulate the robot to do what it's supposed to do based on what is seen in the video or how the emotions it's been captured by a teleoperation of the robot. So do we need a physical form? Does AI need a physical form to learn to be AGI and to be learned to be ASI or artificial superintelligence? I mean, I've heard both sides of the debate. It kind of reminds me of the HBO series Westworld, where the creators of the robot said that intelligence only occurs after pain and suffering uh, and bad things. So you got to constantly be either hurting the robot or damaging the robot or causing the robot some emotional, which is or some kind of stress. Um, so does to create AI, to create smart people, do you need stress? Do you need a physical? Do you need a physical representation? You need a physical form for the AI to interact with its environment to learn to be AGI or artificial superintelligence? Uh, or can it use videos, teleoperation, other things? I think it's a mixture of both. Of course, a lot of people don't talk about when you're training AI, you use a lot of simulation where you put the AI in a simulated environment and then see how it reacts, and it can also learn from that. But this is huge data centers and mainframes, not really mainframes, but huge servers running all these simulations and stuff. That's why NVIDIA is selling so many of their AI chips, and there's so many of these centers popping up everywhere to train the AI. Okay, again, I'm not an expert. I'm just bringing up interesting things that I've heard about or seen or have heard or talked about. So this is not investment advice. I'm just saying there is so many companies out right now working on the humanoid robot, which to me is awesome because when I first started at Robo Games back in 2005, everybody thought humanoid robots were a stupid idea. Now everybody's talking about humanoid robots. And the big thing is, I think everybody needs to remember that without all the work done by Boston Dynamics on their Atlases and Spot robots and Honda's, all the millions and millions of dollars that Honda spent on Asimo, uh, these robot companies today would not be as far as they are in a generalized multi-purpose humanoid robot. So many companies. Okay, I've lost track now. So like I said, this is not an investment device advice. If you want to know what the companies are, just ask AI. AI would actually be glad to tell you all the companies it knows of. So uh, I put this slide in. I'm not I'm not a business person. I'm not an accountant. Uh, I can't tell you how many times I've been in a meeting. I was a software development engineer for a long time. I can't tell you how many meetings I was in where the accountant, the business side was promising the world to our clients, was giving our software functionality it didn't have, capabilities it didn't have, uh, overly optimistic about timelines. So basically, what TAM is total addressable market. So if you think into the future, like futurists love to do, you think into the future and you try to come up with ideas that are probably going to be wrong about what you think the future is going to be like in 10, 15, 20 years. Sometimes even 5 years, it's hard to say what's going to happen. So basically, they were constantly talking about that humanoid robots will be a one for one. For every human in the world, there'll be at least one humanoid robot. That's where they get into this TAM. But the problem with TAM is that if it's not based in some kind of reality as far as cost, as cost goes, or cost per hour, or do we have these capabilities now? Oh, when would we get these capabilities? Does anybody really want a humanoid robot? Um, can AI solve everything? Can AI just come in and solve all the problems that complexity and the errors and the problems that occur when you try to use a humanoid robot with humans? Um, I'm just bringing this up because I'm being pounded by TAM, 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 TAM. Yes, TAM's great. Projecting's great. But let's be realistic. Let's don't promise our clients stuff that we can't deliver now, and at the cost, at the development cost that uh, so a lot of companies are going to go bankrupt because they're promising the world to their clients, and it's going to and they don't have the money or the time to deliver that. And once again, cost. I This 20,000 or less cost to build a humanoid robot, I don't know where that came from. I don't know who came up with that. It just seems like somebody says, "Oh, I think we can build a humanoid robot for $20,000." No offense, Mr. Musk, but that's a projection. And then people took that $20,000 and just went nuts and said, "Oh yeah, we can get that to 10,000. If we make millions and billions of these, then we can get it down to 10,000 per robot to build." I just don't see that yet. Maybe in the future. There is so many components to humanoid robot actuators, uh, pulleys, the computers, the AI, the hardware, the everything is rolled in. The complexity level of humanoid robot, the sensors you need, the vision sensors, the tactile sensors, the pressure sensors, all that kind of stuff. And you got to integrate them all into one package, and it's got to work 100% of the time. You just let's chill on this 10,000 or $20,000 cost to build. I'm an engineer, I know what it costs to build stuff. It's just going to take time. Maybe manufacturing and making millions and getting the cost for cogs or whatever down will get us there. But come on. So here's kind of a breakdown. I've got the link to this report on humanoid robots that you can look at. If you start breaking everything down, the multiple servos, I mean, you're talking 20 plus, 20, 30 actuators, servos, battery packs, wiring, the infrastructure, I mean, are you going to need steel or titanium or aluminum structures, the torque and all that kind of stuff to handle the torque, uh, and the wiring. And not only do you have each component cost, you have to put it together. It just uh, I think their cost was around 60,000. I still don't see that. How is that possible? Maybe in the future, but 60,000 for a humanoid robot with a complexity level, with the software, the integration, the building, the hours. Um, so here's kind of this might be out of date. This is kind of like I said, this is not investment advice. Don't pick robots based on the slide, but the only highlights out of this one is that Unitree's robot has done extraordinary things and has awesome videos. But I kind of wonder if you overstress actuators and frames of robots to do kung fu and gymnastics, and I call it super agility. I just don't know the durabilities there. Of course, you got Boston Dynamics. They've been in this business for over 30 years. Uh, got Tesla, the new startup, the new challenger to the throne, Game of what? Game of Thrones, whatever. Figure AI, good at raising money, good at building robots. I don't know. Somebody else can make that determination. Uh, Agility in their digit. They actually have a factory where they say they mass produce robots in the hundreds that they've built. It'd be cool. It'd be cool to see their factory. I think they work with Amazon. Of course, Tesla has an advantage because they don't have to actually sell their robots. They can build their robot and put it in their factories in the hundreds and thousands, and within a few years they can iterate and produce a fully automated factory that doesn't need a human. Um, the other one I think that's kind of stands out, I heard a little bit more lately about, is Aptronic. Uh, they seem to be getting a lot of funding, a lot of interest from people. Okay, this is where I think humanoid robots will start out originally, initially is in factories. And the reason why, because you can put a big cage around the assembly line and you can protect humans and the environment from the robots until you get them more tested and more developed. I'm still kind of that 24/7, 7 days a week durability. I just don't think it's there. Battery life is not there. You got to swap batteries or charge batteries. You'll have to have multiple robots to do a job. If you're going to have a robot 24/7, you're going to have two or three robots to fill one area or one position because you're going to be constantly charging batteries or maintaining doing maintenance. I mean, how many maintenance hours? I mean, people criticize the Air Force all the time about how many hours they need to maintain their stealth airplanes to stay flying in the stealth mode. For every hour it flies, they need, what, 10, at least 10 hours to or more to keep the robot in proper shape and proper working order. Um, so I don't know. It's going to be interesting to see the cost per hour. Is a humanoid robot really going to be cheaper than a human? Maybe, maybe in the future sometime. So I thought this was an interesting video. This is the traditional way to build a humanoid robot. This is at the Tesla factory. This is a new, very recently published picture. This is the labor, and this is so you got two people. It looks like there's two people, at least in a few of the robots. This is a assembly line. You've got each robot being hand built. At some of these stations, you have two people at a station to build a robot. This is hours and hours of work. Uh, I really need to see a functional end-to-end mass production assembly line before I start saying, oh, there's going to be millions and millions of robots running around, humanoid robots running around at a cheap $20,000 price. When I see this, I think, okay, this is awesome. This looks like they're doing a lot of work. Looks like they're making a lot of progress, but it also shows that maybe we're not, that's pie in the sky, huge TAM, huge profit margins is not quite there yet. Human robots in the home, I think I talked about this a little bit already. I think the biggest thing we need to worry about is that the state of artificial intelligence right now is good, but do you really want an LLM based AI dealing with your kids, dealing with your pets, walking around your house? There's going to be a lot of safety issues happening because of this. So I just want everybody to, to think a little bit about, is this a safe environment? Is being in the home a safe environment? This could be years out. Lots of companies, lots of companies are involved in humanoid robots. The side companies, actuators, everything that comes, the complexity level of humanoid robot, every element in the humanoid robot is going to need a huge supply chain. Uh, some of it is in place, but to create millions and millions of humanoid robots every year, is going to be you're going to have to develop the supply chain for that. So I just warn people, don't say it's going to happen next week when you got to build up the supply chain. Yeah, this is just showing all the different companies. China is really, really going all out on robots and humanoid robots. And I think it's just going to expand more and more in the future. This is a link to that Morgan Stanley report that I read. It was very interesting. As as I'm not a business person, so it was interesting to read. I think it was very optimistic, but it was very interesting to read. So you can check it out. Give me some feedback. What you think about Morgan Stanley and their $60,000 humanoid robot cost to build. So I think the future is bright. I think there's a lot of things that are going to be happening in humanoid robots. It's probably going to, as AI gets better and better and better, as we solve a lot of the AI issues, training issues, uh, hallucination issues, all that kind of stuff. AI is going to make applications for humanoid robots uh, easier to do. It'll unlock the potential of what a humanoid, a general purpose, jack of all trades humanoid robot could do. And of course, the TAM's really high. And I think there's 3D printing involved and so on. But I think we're not quite there. We've got a lot of iteration, lots of iteration needs to be done. Lots of robots need to be out there actually performing worthwhile tasks. And so we can expand and improve and develop further. So finally, kind of wrap this up because I don't want to bore everybody. My favorite topics are robotics and STEM and so on. I do a lot of robotics education. Uh, Work with the first teams. I think encouraging kids to look into STEM, like those careers. I think those careers are still going to be extremely important, extremely valuable, and high demand, especially in the U.S. This is quickly where I work. Mission Lab in Kansas City, Missouri. Do robotics education, STEAM and STEM education. Another view, picture, so on. So I'll kind of wrap it up really fast. I think I've talked about my 7 or so valid points. Humanoid robots are huge potential. Uh, I'm happy that everybody else has kind of come around. In 2005, everybody was like laughing at me because of my uh, as a proponent, as a advocate for humanoid robots. Uh, it's really nice to see that other people are coming around to this and it's becoming extremely important uh, and possible future. Because originally back in 2005, I never thought I would see the development and the potential. I mean, because there's possibility we might have humanoid robots walking around in Mars in the next 6 years. At least that's the promise. Walking around Mars, walking around the moon, doing stuff uh, semi-remotely, semi-teleoperated, using AI to do stuff that, especially in environments like Mars and the moon, where it's kind of hazardous for us to do all this heavy work. Um, if you have any questions, you think I'm wrong, I'm happy to hear response or comments. I'm going to post this video on X and YouTube. So if you want to tell me I'm full of it, that's fine. I don't care. I mean, I learned that. I learned by that. I don't, like I said, I don't know all the answers. Uh, but I'm going to try to do more of these videos and put my thoughts out there because um, just to show people who I am and what I'm thinking and what I think about what's going on. And if you're interested in that, I'd be happy to, I would thank you for watching and listening and thinking and helping and questioning and all that kind of stuff. So that's about it. And uh, I appreciate your time and hope to see you again on my next video. Bye.